So here we have our suction gauge, and when I took this system off, we have these cool little valves called low loss fittings, and there's basically a check valve, so it holds the refrigerant in this hose all the way up to our gauge set. So this is all vapor, so it's not going to be a true saturation, but the temperature is going to affect the pressure. So we can see what our pressure is right now. We're looking at about 130, a little over 130 psi gauge. What we're going to do is we're going to take and put this in the freezer. And then we're also going to look at our high side gauge, the head pressure gauge. This one also has the same type of low loss fitting, a little bit shorter hose, but this is all pure liquid refrigerant in this one. So it's also not going to follow saturation exactly, but we'll take a look at what our pressure is. And we have about 300 psi gauge. So we're also going to put this in the freezer. And the other thing we're going to do is we're going to throw a thermometer in for good measure. So we'll just turn the thermometer on, drop it in here, give that time to settle, and we'll see how that temperature affects the pressure. An example of temperature and pressure is we have this sealed chamber. It's completely sealed up. There's liquid at the bottom. It's approximately the same temperature on both sides. What I'm going to do is put my hand around the bottom side of this. If my hand's on the bottom side of this, it's going to start heating up. Heat's leaving my hand and going to the cooler bottle. What's happening though is it's causing the temperature and the pressure to increase on the lower side. That pressure is pushing up to the cooler bulb at the top. So actually it's called a hand boiler, but it's not truly boiling. It's just a change of pressure and temperature. It's taken the fluid and pushed the fluid towards the top of the bulb. Now if I take and put my hand on the top bulb, the heat is now increasing the pressure on the top side, and it's pushing the liquid, and it's also pushing the vapor into the bottom side. So it's just a matter of temperature and pressure have a correlation. And the closer we get to equalization, the slower that process will happen. So for good measure, we're going to throw this into our freezer as well. So we'll take a look at what our temperature is first. And we're at 16.7, so it didn't fully get time to equalize. We'll take a look at our little hand boiler. So it's pretty frosted up right here. So if I put my hand on the bottom now, ooh, the heat's leaving my hand and going to this refrigerant. So it moves pretty rapidly. Push it all to the top very, very, very quickly. Put our hand on the top, pushes it back to the bottom very, very, very quickly. So pretty little thing. It just demonstrates the difference between temperature and pressure. And let's take a look at our high side gauge. This one is solid liquid. It's not saturation, solid liquid. And we see we've dropped down to 100 psi gauge. And we'll take a look at our suction side, which is also not going to be saturated because it's pure vapor in here. And we can see that our temperature, our pressure is 75, 80, 85, between 85 and 90, so let's call it 88 psi gauge. Now this is not saturation because it's pure vapor. This is not saturation because it's pure liquid, but temperature and pressure does have its correlation. Now if I have my refrigerant tank, this is a brand new tank of refrigerant. This is HFC, hydrofluorocarbon 410A. So this refrigerant, as long as there's liquid and vapor in the tank, if there was liquid and vapor, and I was to put this inside of the freezer with a pressure gauge attached to it, the temperature of the tank and the pressure gauge would match our saturation chart. The same thing as I took this back out. As long as there's liquid and vapor together, it will match the temperature and pressure chart. The problem is it's not going to fit very well inside of our freezer, and the wife doesn't like me taking up all the space for refrigeration stuff. We could do the same thing in the oven. We could put it in the oven, raise the temperature, and also raise the pressure, but it's quite dangerous putting this refrigerant tank in the oven, as well as your wife probably won't like it as well. So temperature and pressure, they go hand in hand. As long as there's liquid and vapor, we can track it on the saturated temperature pressure chart. It's also another way that we can test refrigerants. If we have a tank of refrigerant, we don't know what it is, we could actually hook our suction pressure gauge to the tank, open it up, measure the pressure in the tank, also measure the temperature of the tank, and we can look on our TMP chart and find out what refrigerant matches the temperature to that pressure.